Hello, Takasur. Hello, Mike.
Hi, Takasur. Hi, Caio.
Hello, everyone.
Thank you for joining us live. So, are you an iOS developer?
Yes, recently I have joined a company after a long time. I was actually a self-learned programmer, so it is my first actual job in the industry.
Awesome.
For how long have you been a developer?
3 years.
3 years. Awesome. How can we help you?
Yeah, I have problem with the design architecture patterns because if I am to start a project from scratch, I can choose any pattern that suits me. But when you work in a company, there are so many running projects, and some of the projects are in MVC, and by MVC I mean massive view controllers and some massive controllers as well. There was a file I was reading, and it had more than 2,000 lines of code in it. And I was like, oh, how am I going to debug this file if I ever have to encounter any error or something like that?
Yeah.
Mm-hmm. I've been there. I know.
Yeah.
Wow. Yes. Okay. So the question is how to solve the massive view controller?
Yes, exactly. And like sometimes your organization want you to use model view model specifically. And there are so many implementations of MVVM, especially with the iOS 13. There's combined framework, and there's implementation with the combined framework. And I guess some people have implemented their own observers using couriers and stuff like that. And there are so many other variants as well. Some people modify the MVC a little and call it MVVM. So I could not find any suitable implementation for the MVVM. But the MVP, it was very simple, and everyone has almost the same implementation for the MVP. And about CleanSwift, I went to the website, and the tutorial was outdated. The latest template the Raymond Law is going to send you is very different than the tutorial on his website. So there's no valid implementation for the CleanSwift either.
Yeah. So those patterns here, they are more guidelines rather than specifically telling you this is how you need to implement MVC or MVVM or MVP. They are guidelines. And you adapt those guidelines to whatever makes sense to your case, to your project. Right? That's why you will see many variations, some good variations and not so good variations. Right? But there are many ways you can follow the principles of separating your components into these 3 layers in the user interface. They will make your code more maintainable if you follow the patterns, and make good decisions for the problem you're trying to solve. And that's why there are many ways to implement it. There's not one true way, which is the best way. It's the best way in context for your specific scenario, right? So those patterns, they are adapted to whatever framework you're using or to whatever challenges you're trying to do, whatever user interface you're implementing. Some are simpler, some are more complex. Some have only 2 elements, some have thousands of elements on screen. And the pattern we will choose and how you will implement those patterns may vary. And that's why you see many different implementations of the patterns.
Yes, exactly.
For example, sorry.
Please continue.
Oh, I was going to say that if you read for example, the design patterns book, the Gang of Four book, they say that the patterns, they are not final, right? They are, how do they say it? What are the words they use? It's pretty much like, they're not like a recipe that you need to follow exactly as they're saying it, but they are guidelines. And you adapt those guidelines to whatever makes sense to you. And they show many variations in the books as well. In the books, they show, you can implement the observer like this, like this, like this, like this, or like this, or like that, in many, many different ways of implementing the same patterns and adapting a little bit to whatever makes sense to your project.
Yes.
So even though like the MVVM and MVP, they are variations of the MVC pattern as well. And you will see many implementations of all of them. For example, the original.
But the MVP by far is simplest to understand and follow because of the simple delegation pattern, I guess.
Yes.
Yeah.
But the MVC is pretty simple as well. Like, so this is the original MVC at the time, in 1979. Imagine how computers were at the time, how the user interfaces were at the time. They were not as fancy and as complex, probably, as some UI we have to implement today. Where you can fit much more elements on a phone screen than we could on a computer back in the day, right?
Yes.
And we do many more, try to do at least more fancy things, because they actually had complex applications back in the day. I mean, they sent people to the moon, right? So the idea was the user would interact with a keyboard or with a mouse, with something, and that input the user was sending, those events, would go through a controller. This controller would process that event of pressing a keyboard key or, clicking on the mouse, doing some event with some input into the computer. The controller would receive that input, try to figure out what happened there. Oh, the key K was pressed. It would unpack that event, send a message to the model. The model will process the data, maybe validate the input, do something, and update its state. When the state was updated, the view will be observing changes to the model. You will have an observation, like observer relationship with the model. Every time the model changed, the view will receive some kind of callback, some kind of notification, and update itself. So the user would see the change on screen. And this loop would carry on over and over. That was pretty much the original idea in implementation. But the main idea is not even this relationship here, but the idea of separating your user interface into 3 layers, 3 logical layers. One for controlling events that happen, one for the business logic, for the data manipulation, and another one for the presentation, for the rendering. That was the main idea, separate things in layers. So when you think about MVC, you shouldn't just think about there is a view class, a model class, or a controller class. I like to think more of there's a controller layer. Inside that layer might be many classes interacting with each other. Inside the model layer, there might be many classes in there, like domain objects, there might be data transfer objects, there might be services, model controllers, interactors, And on the view side, you can have many views, delegates, as you mentioned, like callbacks, and so on. And that's the main idea, separate things into 3 logical layers in the user interface, which makes things simpler to develop, maintain. It's all back to the principle that we always try to achieve with software, separation of concerns. Separating concerns in logical units that can be developed, tested, and deployed independently. Now, how those components, those layers communicate between themselves is what start varying a lot. For example, in the Apple recommendation, right, with UIKit back in the day, was a bit different than this initial model, where the controller would sit in between the model and the view layers. And every time there's a change in the model, the controller would receive this through some kind of notification, callback, and update the view. And every time the view receives some event, you will go through the controller, through a delegate, through some kind of target action pattern. There are many patterns here, callbacks, and the controller would update the model. And the controller would mediate this communication between the view and the model. This way, the view usually don't depend on the model layer, and the model layer don't depend on the view. The controller sits in the middle of them and bridges this communication. And here, as you can see, the model also does not depend on the view. This communication here is to some kind of callback listeners. And the controller here doesn't need to depend on the view. on the model. It doesn't depend on the controller or the view as well. Why? Because you could get the same model and deploy in a different application with a different view, with a different controller, and it should work. Because you want to decouple the model layer from the user interface. Thus, you can use the same model layer with different user interfaces.
Okay, so I have a quick question about MVC by Apple, because in many implementations, what is we use notifications or very much we rather opt in for closures, I guess, more often.
Nowadays, yes.
Nowadays, but in some code base, I found excessive use of notifications and notification center library by Apple, which was previously, I guess, NS notification. So, like, why do people not use the NS notification center anymore?
Okay.
Because nowadays we have better ways of doing it, right? With closures, for example. Like back in the day, in Objective-C, there was a time you had no blocks, you had no closures, right?
Not that far, you know.
Yeah.
Like 2010.
You didn't have the concept of blocks or closures.
Yeah.
So everything will be through delegation or the target action pattern.
Yeah.
There were no callbacks. Like there would be delegation, target action, or notification center, which is like this global singleton that everyone can listen to events and send events to, right?
All right.
And it still works, you know. For example, if you're using core data, it still fires notifications. You can listen if you want to. You can still use notification center. But with callbacks, the need to use notification centers pretty much decreased, I believe. And also we found better patterns. The platform matured in a way where you can have a design that doesn't depend on global notifications.
Yeah.
But there are scenarios where notifications are still handy, especially if you're creating frameworks like core data.
Yeah.
But it's easy to abuse. Everything is easy to abuse, you know. You can use like even callbacks you can abuse and use too much as well and start having issues.
Yeah, I remember I used a nested callback and it was not returning the data at all. So I then refactored the code to use delegation and the MVP pattern.
So some variations here. What happens is that creating this mediator here, this controller, to bridge this communication, introduces a lot of boilerplate code. And the idea with MVC is not to have one model, one controller, and one view per screen. The initial idea with MVC is to have many MVCs collaborating with each other in a screen. So a button will have its model, its view, and its controller. Another button would have its own. A text field would have its own MVC. And everything, the whole screen would be a composition of many MVCs. It was just hard to do this with UIKit back in the day until they introduced the container APIs, where you can add controllers inside controllers and create relationship between controllers. But that was always the recommendation. Instead of having one model, one controller, and one view per screen, you can have many and compose them into the screen. Thus, you can solve every problem on its own and make them communicate through some kind of delegation, some kind of callbacks, and they can, notifications and talk to each other. But that was the idea. And the problem with massive view controllers is that you try to put everything in one controller, everything in one view, everything in one model. But if you break down, there's nothing wrong with MVC. If you break down MVC in a screen into many MVCs, every MVC doing its own job and communicating between each other, you don't have problems. You have small controllers that communicate between each other very nicely.
Exactly. The problem is what you mentioned in the beginning, that you have, one class, basically one view controller with 2,000 lines. So everything is concentrated in there. That's a problem.
Yes, that is a problem. There's a massive problem.
Yeah.
Not a problem.
And also creating these delegations, creating these delegates and listening to them. And then when something happens, you pass this data to the view. And when the view responds, you also get and pass this to the model. That's a lot of boilerplate that people notice that you can pretty much eliminate a boilerplate with some kind of binder framework that does all that for you. You just say, hey, bind this model with this view, and that's it. Do its job. You don't need to be writing hundreds and hundreds of lines of code to do it. And they started calling this model view model, which is a variation of MVC. It's because you still have the model layer here, and you would have a view model, which is a specialized version of the model that converts what the model provides with data, actions, and so on, into what the view layer expects and needs. And you will bind them.
It converts the massive model into a more shrinked version for the view.
Yeah, it doesn't need to be a massive model. It could be just like the model is not trying to provide what the view wants. For example, the model may have a date. Let's say you have a model here that has a date object. Let's say the view doesn't know how to render a date. So you need to convert it into a string, right? So the view model will do that translation between what's in the model and what the view needs. So we need to convert this date into actually let's say something like this, like January 22, 2021, which is a string, right?
Yeah.
But this date here is just a float. Like something like that.
Yeah.
Make sense?
Yes.
And the view can render this, for example. It's pretty much the idea. Create a model specific for the view with what the view needs, without polluting view logic, presentation logic into the model. Thus, the model can still be used with other user interfaces. If there's another user interface, you create another representation of that data, another view model, and another view. But the same model still. And you eliminate all the boilerplate between listening, the view, events, and then converting all that. No, you just create a view model that will provide the translations, whatever actions the view needs. And the binding will go through some binding mechanism, like, let's say, Rx Swift, combine, or I don't know. At Microsoft, they created this XAML thing that we would define the binding in XML, and it would automatically work. That was the idea, eliminate boilerplate. But it's still the same concept of 3 tiers, 3 layers. And then MVP, which is very similar as well. You still have the model layer. And again, think of this not as a class model, but as a model layer. And you can have many services, model controllers, interactors, whatever you call it here. Then you have the presenter. It usually talks to this layer, get responses here, translate that into data, view model data. Usually creates here view data or view model. You know, view models, that only holds data. It translates that model data into view data. The same, it would translate date to a string here, for example. So the view can render that data. And it communicates with the view through an interface. And when there's an event, the view usually sends that event to the presenter. And it creates this two-way communication, where the view talks to the presenter talks to the view, which can create a return cycle. That's why usually the presenter holds a weak reference to the view in presenters, right?
Yes.
To avoid this
exactly.
return cycle here. There are variations of the MVP pattern as well, just like there are variations of the MVVM and MVC patterns. For example, you can eliminate this dependency here from the view talking directly to the presenter. And what can happen is the view talks directly to components in the model layer somehow, to some kind of delegation, notification, you compose them, some kind of closure protocol. And the view events will be translated directly to model actions. When the model changes somehow, the presenter will be notified to, again, could be through delegation, callbacks, and so on. And the presenter translates that event into some presentable data to the view, sends it to the view. And then you create this unidirectional flow.
Yeah.
And then it creates a unidirectional flow instead of this two-way communication flow. And you avoid that retain cycle in here.
Right.
So you can vary this depending on your needs. That's why you would not find the best or the correct implementation of MVC. The correct implementation depends on the context where you are applying the pattern.
It's important to understand.
And which framework you're using, For example, it's quite cumbersome to implement MVC in this way, like UIKit, if you're using SwiftUI. Can you do it? Yes, absolutely. You can create a controller and put that in the middle and pass a reference. It's just fighting the framework, right? So you probably will see more an MVVM style where you provide this view model that translates whatever happens in the model layer to what the view needs. And we'll bind them with the combined published wrappers, state wrappers, observe object, and so on. You get all that binding for free. You don't need to be writing a bunch of boilerplate code. But you can still implement MVP with SwiftUI. We showed it in the professional iOS engineering series on YouTube.
Mm-hmm.
Check it out.
I'll definitely check them out.
Yeah, there are many more videos also demonstrating the differences of the patterns and various designs that you can have. So make sure to check the whole channel out.
Yes, check the Clean iOS architecture series playlist. Also on YouTube, we talk about all those patterns. Even Viper. But again, those patterns here are for the user interface.
Yeah.
I don't consider them like, oh, what is the app architecture of my application? MVC. No. I use MVC in the user interface. But the architecture of my application contains much more than view models and controllers.
Yeah.
So yeah, we can sometimes use a mix of these architectures in our application, I guess.
Yes, but you want to avoid as well the Frankenstein application where every screen follows a different pattern, and then it's very hard to kind of know what's going on because there's no standard, there's no, exactly. Clear pattern. So yes, you can, say, oh, this screen would probably benefit from having a presenter, but don't vary too much. Like every screen in the application is 100% different. It would create a lot of confusion probably in the code base. But you can vary those patterns, depends on the frameworks you're using, depending on the needs of the project. For example, MVVM, usually you create a view model for a specific view. Thus, the view model will depend, if it's a UI kit application, this view model will contain like UI colors, UI details, that are specific to UI kit. Then, if you want to use a different framework here, you won't be able to, because the view model is coupled to the platform, coupled to the framework. If you want to deploy this on macOS, for example, it's not going to work because you don't run UIKit on macOS, unless you're using Catalyst, but then you have other issues. So what do? You decoupled your view model from the specific framework you're using, from the specific user interface, and you create a platform agnostic view model. And then you can plug different UI here. And you can use the same view model on macOS with AppKit and iOS with SwiftUI or UIKit and so on. But again, that's a decision you need to make depending on your application. If you want to deploy that application in multiple platforms, maybe you need to decouple your view models from the specific framework. Otherwise, you just couple the view model with that framework. So it's a choice you're going to have to make. That will change a little bit the implementation depending on the needs you have in your project. And I think the MVP is easier to reason about, as you mentioned, because you're dealing with more basic constructs that you get from the language, like protocols and callbacks, rather than using binders, XML, or combine RX Swift, which brings some extra complexity for sure. Yeah.
Yes.
Make sense?
Yes, definitely.
So there's no one true way of implementing those patterns, but there are definitely bad ways of implementing them.
Yeah, I've seen them.
like massive view controllers with 2,000 lines of code. If you split that massive view controller into many tiny MVCs, you'll probably have a better time.
Yeah, I was thinking that if I am going to work on that project in a long term, so I will create multiple extensions to that file, which has like 2,000 lines of code. So if I am to debug something that I have added to the application, that will be easier for me.
Yeah, there can be a start. Start with extensions, and when you have isolated extensions, they can become their own classes. They are completely decoupled from the rest of the code. Absolutely. Also, you need to be careful that some people say, wow, MVC is terrible. I have a 2,000 lines controller. I'm going to use MVVM because it's going to help my problem. And then you have a 2,000 lines view model.
Yeah, that can happen.
That can happen. Or a 2,000 lines presenter. That happens a lot as well.
Yeah.
It's about separating concerns and try to create smaller things. That's going to make a life easier. And compose them. Create smaller things that are composable.
Yeah, I guess that problem originates from schools as well, because model, in my understanding, has always been just the entries, the business objects, and I never thought that the model can contain business logic as well, like formatting the date. I thought that everything that goes into the controller. But even in my implementation, I would always create a separate controller for the business logic instead of using the view controller, because I did know somehow that the view controller in iOS is just for the view thing, like for animations or setting up constraints and everything, or what happens when the button is tapped. So I did always create a controller, but again, the controller can grow, and separating the controller and dividing it into multiple files is necessary.
Yeah, if you don't separate concerns, everything will be in the same class. It will be very hard to test, to reason about, to change, to reuse the logic as well. And try to think this more as layers rather than as classes. Otherwise, you are too fixed in putting everything into one specific class, right? So think of a layer. Controller layer may have many classes in this layer here to help like bridge this communication. In the view layer, you have many views. And usually people get the view layer correct. Yeah. Because you don't have only one view that does everything. You have many views. You have a UI button, and then you compose the UI button with a label and with another thing in a stack view, and then you have many views, and usually we get this right. But then we control all those hundreds of views with one controller, rather than creating many controllers, separating logical units and say, okay, what this controller will control? Oh, only this view or only these two views. Okay, and if this is starting to become more complex, let's break it down into another controller and make them communicate. So think more as layers rather than one view, one controller, one class. No, actually many views, many controllers, many models.
Or even one view, many controllers, and many models.
Absolutely.
Yeah.
It could be.
Could be.
Yes.
And then
if you have the layout separated as well, like that's perfect.
Yeah, like
you can start with the
like if there's a table view with collection view in it, and every row has a collection view of its own, and that collection view has some buttons or images, then there's a single table view with nested multiple views, and then they can have their different controllers rather than one big controller.
Yeah, each cell, for example, could have a controller.
Yes. But it's always, I find it always helpful to create a separate nib file for cell and have its own controller and make them talk to each other, preferably with presenters or delegation or callbacks if needed.
That's it. Sounds good. And you can start, for example, with a controller that also does layout and also is the collection view data source. But with time, maybe you can move that logic to, for example, in the controller layer here, you can say, you know what, I'm going to create an actual collection view data source. Let's say you're presenting a list of users or photos. So then you have a photos data source. The class specialized to implement the data source methods and populate the table view. Doesn't need to be in a controller anymore, right? And then you can reuse the same data source with different controllers. And boom, you get instant reusability. If that's something you need in your project, you can go down this route as well. And then the layout as well. Well, I can also separate it into a photos layout class. So on, like nothing stops you from breaking down into the different classes rather than putting everything in the controller. And each cell is a controller as well, like a photos cell controller. And each instance of a cell has its own controller that manages the state there and the interactions. Works pretty well.
Yeah, exactly. I have found it helpful in a recent project I have been working from scratch. And it was very helpful to have a separate cell class for every cell, even if the cell was very basic or simple. Because in a project I was working, the view was like very messed up. It had a view on top of a view on top of view, and the main cell view was underneath everything. So if I was to change the color or something of a particular label or button, it was very difficult navigating to that particular view because everything is a single view controller storyboard file.
Absolutely. Yeah. Separation of concerns. That's the
separation of concerns is must to be implemented on the views as well. People just sometimes just implementing it on the controller or the model, they forget about the view, I guess.
Absolutely. And back in the day, we would avoid creating many classes, for example, for each cell, because there will be a performance penalty, like with the iPhone 1. You would make a huge difference. But nowadays, we have enough processing power that we can, make some measure, of course, before optimizing. And, we have more leeway to have a better design as well. But you should always measure performance, because adding those extra classes may impact performance depending on the devices you still support. May use more battery as well, more allocations, more memory usage. So we need to be, always monitoring and optimize when needed. All right. So that was an overview of MVC, MVM, MVP, and why they vary. Again, check the Professional iOS Engineering series.
Make sure
it's a playlist as well on YouTube. The Clean iOS Architecture, also playlist on YouTube. right. Thank you for joining us.
Absolutely.
Great questions.
Yeah. Thank you so much, Takasur.
You're welcome. Okay. Bye.
Bye. Take care.
Take care. Bye.